Hello again, everybody, and welcome to another weather PowerPoint. This is PowerPoint number 6. Sound effects, right? Weather tools and, I'm in the way, technology. This time we're going to be looking at different weather instruments and explaining how each one is used and how they're used in gathering weather and telling us what tomorrow's forecast is going to be. So, speaking of forecast, before the weatherman on TV can tell us what the weather's going to be doing tomorrow, he'll need to check a few things. He needs to check the temperature, barometric pressure, the humidity, the wind speed, the wind direction, and look at the radar. Basically, he needs to use his weather tools. I could be a weatherman. First one we're going to look at is the thermometer. One of the first tools that a weatherman will use is the thermometer. A thermometer tells us what the air temperature is. Oh, look, down there, over there. See it? It's a boldface underlined word. That means I need to pause and write that down real quick and then unpause and keep listening. Okay. You done? Good. This tells us what the air temperature is. Basically, is it hot? Is it cold outside? There's two different scales that we commonly use to tell the temperature, Celsius and Fahrenheit. Using the Celsius scale, water freezes at 0 degrees and water boils at 100 degrees. Using the Fahrenheit scale, the water freezes at 32 degrees and boils at 212 degrees. Barometer. It's not a barometer. Just saying. Barometer measures the air pressure, the atmospheric air pressure, that is. And if you remember, when a cold air mass is over the area, it's called a high pressure system. And when a warm air mass is over the area, it's called a low pressure system. Speaking, what a concept. Well, the term high and low pressure refer to the barometric pressure of that air mass. When the air above us is cool, it falls to the ground, which increases the air pressure. And this in turn falls down here and pushes down on this little aneroid cell, squeezes it, and makes the needle rise higher. When the air above us is warm, it rises upward, which decreases the air pressure. So basically, the air goes up, the air pressure is rising, so there's less air pressure. This lets the aneroid cell expand and then allows the needle to fall, and thus this is basically how a barometer works. The barometer measures the change in the air pressure. Low pressure means that there's warm, moist air and just right for rain or storms. High pressure means there's cool, dry air, which brings fair skies. Our next tool that we're going to look at is the hygrometer. Not a hygrometer, hygrometer. Can you say hygrometer? I knew you could. Hygrometer measures the humidity in the air. Humidity refers to the amount of water vapor that is in the air. The warmer the air is, the more water vapor it can hold. Our next one up is an anemometer. An anemometer, I can't say anemometer. You can say hygrometer. I can't say anemometer. Something's wrong here. Anemometer measures the wind speed. The cups on the wheel catch the wind much like a pinwheel. You know, that little thing you had with all the little shinies on it. You blew on it and spun around, 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 around. That's the same thing here. It's an anemometer. The wind blows in that little cup, which makes this whole thing spin around. The harder the wind blows, the faster it spins. Here's what I just said. No, don't do that. And this particular anemometer is hooked up to a little generator down here. So the harder this spins, the faster it turns the generator. Generator's got a little cable, which is hooked up to a little speedometer, which will go faster or slower depending on how fast the wind is blowing. Now, Windvane. This is probably one of the oldest weather tools that we have, and the Windvane tells us what direction the wind is currently blowing from. This is very common on top of barns and older buildings back in the day. Today, you don't see them as much. This is what you see. This has got a little weighted end and a big fin at this end, and when the wind blows across, it causes this to spin and turn in a given direction. Now, inside this casing here is a little sensor thingy, and when it turns, the sensor inside tells which way it's turning, which will read out on a gauge or on a computer somewhere else in some other room. So it's all high tech now. No barn required. And a rain gauge, our next one. A rain gauge is used to measure the amount of rainfall or precipitation over a period of time. Now, rain gauges are incredibly complicated systems that require a cup and a ruler. All right, so they're not that complicated. And basically, that's just it. It's a cup and a ruler, and it's nothing more than that. They mark the lines off on the side, which tells us the centimeters, the millimeters, the inches, the quarter inches, however, whatever system we're using to measure it with. Rain falls into the cup. It stops raining. You look at the cup and go, 3 inches. And there you go. You have read the incredibly complicated rain gauge. All you need to do is basically sit outside and wait for it to rain, then measure the amount of water in the glass when it stops. Dump it out at the end so you get a fresh rainfall count the next time it rains. Radar! This is actually one of the coolest ones we got. A radar is a system that sends out pulses of energy that bounce off the clouds and then return to the radar. A computer receives and processes the signals and then builds a picture of what clouds look like over a given area. And it looks a little something like this. This is actually Atlanta, and we are up here-ish somewhere, and as you can see, according to this picture on this date, we are getting a great big huge storm, and a lot of rain is falling. Along with our radar, our weathermen can also use images taken by satellites. This is the Geostationary Operational Environmental Satellite, otherwise known as GOES. It orbits our planet at a distance of around 22,000 miles out in space above the Earth's surface. The GOES are highly advanced observation platforms and are supplying detailed imagery of the Earth almost every second of every day. How advanced, you might ask? Well, it's this advanced. We've got a big old antenna up here in various bandwidths that send various signals back and forth to the Earth, a super double extra powerful camera lens, X-ray sensors and solar cells and telescopes and stuff and things, and it's really quite cool. And what does it look like for real? Well, it's about this big. That is an average sized guy standing next to it. You can see right here, that's the lens on the really powerful camera. There are some 400 military and civilian satellites orbiting above the Earth that are used just for telling the weather. Now, this is a lot more than 400 dots, but this is a representation of multiple satellites that have been put up around our planet by our country and other European nations, and it's a pretty busy place up there. Satellites can take many different images of the planet at the same time, and this is what makes them such an incredibly powerful weather tool to have. This is what the visible clouds look like. And as you can see, there's a lot of clouds over the Atlantic, and Georgia over here is getting some cloudy stuff in the Gulf. This is what Hurricane Katrina looked like on August 29th, 2005 at 1:15 in the afternoon, just as the eye of the storm was about to make landfall. This is another satellite image of clouds. As you can see here, there's a lot of clouds over the Georgia area, but sunny as always in Florida. This is water vapor, or the H word, humidity. That's right, very good. So you guys are on this. And you can see that this area here has a lot of water vapor, as does this area over in the tropics. And is it any coincidence that if we go to the infrared camera, which shows storm activity, that these are the areas that are getting a lot of rain right now? Coincidence? No, actually, it's not. Satellites can be positioned so far out that they can actually look at the entire planet all at once. We can also use computers to assemble multiple, sorry, I had to move myself there, multiple satellite pictures from around the planet and showing pieces parts, but in a lot more detail. All right, quiz time. I know you're excited. I know. Here we go. I want you to hit pause right now, and I would like for you to answer these questions. Go ahead and unpause me when you're done. Ready, and pause. You done? Good. All right, so here we go. Let's go ahead and go over the answers. Question number 1, what measures the wind speed? Of course, that is an anemometer. Question number 2, what measures the air temperature? That, of course, is the thermometer. Question number 3, what measures the amount of precipitation? Rain gauge. Question number 4, what measures the humidity? A hygrometer. And question number 5, what measures the air pressure? A barometer. Very good, everybody. If you got all 5 of those correct, give yourself a pat on the shoulder. Job well done. And if you didn't, you might want to go back and watch the video one more time and just make sure that you're up to date on everything we just went over. Thank you all for watching, and we'll see you soon.